Our next application deals with distance, rate, and time. And so the equation that we use is d equals rt. And again, we can always manipulate that equation to make it fit our situation. So looking at our first example, we have a hiker who's hiking 1 mile per hour faster downhill to the lake than she can hiking back uphill to the campsite. So, then it tells us how long does it take her to go each direction. So the good news here is that we know that the distance between her campsite and Moose Lake is the same whether she's going uphill or downhill. So that's the distance is the same, which helps us. So just like we did with our interest rate problem, I'm going to use R times T. So the rate times time going uphill should be the same as the rate times time going downhill. So I'm going to do uphill, rate times time equals downhill, rate times time. So that's just going to help me to know how to set up the equation. Now, of course, I need to figure out exactly how to set up the question. So looking at this last sentence is, what is her speed hiking back to the campsite? I always like to set my variable equal to whatever the question is. So the question is, what is her speed hiking back to the campsite? The other piece of information they give us is that the hiker can hike 1 mile per hour faster downhill to the lake. So the hiking speed back to the campsite is a little bit slower than going back to the lake because obviously downhill it's easier. So if we call x the speed back to the campsite, then x plus 1, that 1 mile per hour faster plus 1, would be the downhill speed. So notice the speed is going to be our x if we're going uphill, and x plus 1 if we're going downhill. So over here, now we're going to try to write our equation. The uphill rate is x. The time going uphill is 4.5 hours. The downhill rate is x plus 1. Rate is speed, x plus 1. The time to go downhill is the 3 hours, 3 hours to the lake. So here's my equation. I'm setting rate times time uphill equal to rate times time downhill because those two distances are the same. And now I'm going to solve. This is 4.5x. And then on this side, I'm going to distribute 3x plus 3. I'm going to subtract 3x from each side. And that's going to give me 1.5x equals 3. And divide by 1.5. And that's going to give me that x equals 2. And of course, this is a story problem. So her speed by hiking back to the campsite is 2 miles per hour. And of course, I would write a sentence, but I don't have enough room to do that. Go ahead and try the second one and then see how you did. So the second one, we're dealing with a rainstorm, and she's driving 15 miles per hour slower. Of course, this is a rate, 15 miles per hour slower on a trip to her mother's house than she normally would when the weather is clear. So it's a bad rainstorm, she's slowed down. The trip to her mother's house takes 3.7 hours in clear weather and 5 hours in a bad storm. And we're trying to find out her normal driving speed. Normal driving speed. So we're trying to figure out that rate. Again, in this instance, the distance is the same driving to her mother's house or driving back. So the distance is not something we're concerned about. So we're going to do rate times time in the bad weather and rate times time in the not so good weather. So her normal speed is going to be x. And she's driving 15 miles per hour slower when it's bad weather. So bad weather speed, she's doing x minus 15. So her normal speed minus 15 miles per hour. So those are going to be our two rates. This is a rate, and this is a rate. So if the trip to her mother's house takes 3.75 hours in clear weather, so that's normal speed, so that's rate of x times time of 3.75 hours. That's in clear weather. And then in bad weather, it is rate of x minus 15 and time of 5 hours. And so when we solve, we're going to solve for x, and that's going to give us her speed in clear weather. That's why we always set x equal to whatever the question is asked, if we can. This side I have 3.75. This side I have 5x and 75. Oops, I forgot my x over here. Now I'm going to subtract my 5x to get all of my x's to one side. On this side, I get 1.25x negative, and this side I get negative 75. And then when I divide, I get x equals 60. And of course, I'm trying to find out her speed, and her speed is 60 miles per hour. Again, I would write a sentence. This is how I know what that label is going to be, but 60 miles per hour would be her speed.